Okay, this is our sixth lesson on solving quadratic equations. Some of you have probably noticed that we've been almost robotically doing the exact same steps every time for the last two blocks. Well, today we're going to see that lots of other people have noticed that as well, including people hundreds of years ago. And basically we're going to do it with a general equation, and then in theory you'd never have to do it again. So let's start by doing just one of the questions we've been working on lately. So let's have a look at x squared, that's terrible x squared plus 4x minus 11 equals 0. And I'm going to label that step 1. And then in step 2, I go x plus 2 squared, and that has to be plus 4 minus 4 because that's 2 squared. And then I get negative 4 and negative 11 is minus 15 equals 0. For step 3, I'm going to add 15 to both sides. And that leaves me with x plus 2 squared equals 15. Now in step 4, we're going to square root both sides. And that leaves me with the absolute value of x plus 2 equals plus or minus root 15. Oops, sorry. Equals root 15. And then in step 6, sorry, that's a regular 2, it looked like a negative 2. We get x plus 2 has to equal plus or minus root 15. And then last step, subtract 2 from both sides, and we end up with our answer, x equals negative 2 plus or minus root 15. And those are the two values that will make that equation true. Okay, in part 2 on the other side, we're going to do the exact same steps, but with x squared plus bx plus c equals 0. So step 1, I have x squared plus bx, leave a nice big space, plus c equals 0. And then in step 2, I have to take half of b, which is b over 2, put it in there squared. And then I need to add b over 2 squared, which is b squared over 4, and subtract b over 2 squared, b squared over 4. Okay, and now these two things are the same. So on the outside, I'm left with negative b squared over 4 plus c. And now step 3, I move the 15 over, so in this case I need to move everything outside of the squared over. So I'm going to add b squared over 4, both sides, and I'm going to subtract c from both sides. And that gets me x plus b over 2 squared equals b squared over 4 minus c. And in step 4, I square rooted both sides. So that gives me absolute value of x plus b over 2 equals, and now let's get a common denominator inside here, so that's going to give me the square root of b squared over 4 minus 4c over 4. Now I've got a common denominator, so I can add those two. So number 6, x plus b over 2 is going to equal plus or minus the square root of b squared minus 4c over 4. And now I'm going to subtract b over 2 from both sides. Which gives me my final answer. x equals negative b over 2 plus or minus, and notice that because that's over 4, we can go b squared minus 4c over 2. Just clean up that c, looks a bit 2-ish. And now I've still got a common denominator, so I get x equals negative b plus or minus the square root of b squared minus 4c all over 2. Okay, so notice, if I ever have an equation, x squared plus bx plus c equals 0, then that'll be the solution. And notice that if I did have an a here, I could just divide both sides by a, and I would basically end up with, a 1 in front of the x squared, and I could still use this equation. Okay? It's a little bit more complicated, but in the textbook they do it with ax squared plus bx plus c. It gets a little bit messier, and you end up with this equation here at the top of the second page. Notice it's very similar to the equation we did, it just has a couple of a's in it. Okay, question 3. Notice that this equation is undefined when a equals 0. Why don't we bother writing it? Well, if a was 0, we'd actually just have bx plus c, in which case it'd take us 2 seconds to solve it, and there's no way we'd bother using this equation anyways. So that's why we don't bother writing that description. Okay? Because this formula is kind of big and messy, what I recommend doing is we define d, big D, as b squared minus 4ac. Notice that's what's inside the root up here. So instead of having this big nasty thing now, we can figure out d first, and then just put d inside that root. Makes the questions a lot easier. And it also makes tomorrow's lesson easier because we'll be talking about big D. Notice that on tests and quizzes you will be given the formula at the top of the page, and you'll have to just separate out big D, which I don't think is a big deal. Okay, so in this guy, first thing we need to check is that we've got x squared plus something x plus something or minus something equals 0. If we don't have everything on the same side equaling 0, then we can't use the quadratic formula. So sometimes it'll take a bit of rearranging. In this case it won't. So our a is going to be 1, our b is going to be 3, and our c is going to be negative 18. So let's figure out big D first. Remember that's b squared minus 4ac, which you don't need to memorize, you just need to know where to find it in the formula. So big D is going to be that, and I'm going to get big D equals 81. So x is going to equal negative b plus or minus the square root of big D all over 2a. So in this case, it's going to be that. And that is going to give us negative 3 plus or minus 9 all over 2, which means that x is 3 or negative 6. Okay, and let's do a quick check, make sure that worked. And that's true. And that guy's also true. Okay, so notice basically we've done all of the steps, rearranged it into this new form, and now we can just take a, b, and c, fire it into these two equations, and it spits our answer out. Okay, again for question 5, everything's on one side, 0 on the other side. So our a is 1, our b is negative 1, and our c is 4. So big D is going to equal negative 1 squared minus 4 times 1 times 4. Big D is going to be negative 15. So x is going to equal negative 1 plus or minus root negative 15 all over 2 times 1. And because we've got the square root of a negative, we have no solution. Notice that we can tell right away that if d is negative, that we're going to have no solution because we're going to have to square root it. And that is what we're going to talk about tomorrow. Tomorrow's lesson is just going to be about big D. Okay, this guy, we can't find A, B, and C yet because it's a freaking mess. So let's clean it up first. First thing we need to do is expand through these two brackets here. So 2x is going to equal 3. Notice that's not the first thing we had to do. We could have multiplied the 3 in first. Notice that x minus 1, x plus 1 is actually just the factored form of x squared minus 1. You could have done that the long way. And now let's multiply the 3 through here. 2x equals 3x squared minus 3. And we still can't find a, b, and c because they're not all on the same side. So let's subtract 2x from both sides, and we get 0 equals 3x squared minus 2x minus 3. And now, finally, we can find a, b, and c. Okay, so there's our ABC. Let's find big D. Oops. B is negative 2, not negative 2x. So D is going to equal negative 2 squared minus 4, 3, negative 3. So big D is going to be 40. So x is going to equal negative negative 2 plus minus the square root of 40 all over 6. So x is going to equal 2 plus or minus 2 root 10 all over 6. Notice we can reduce top and bottom by 2. So we get x equals 1 plus or minus root 10 all over 3. And there is your solution. If I were to ask you for a check on this, remember you can use a decimal check. Alright, here's part B. Got some fractions here. You know, the first thing I'm going to do here is just get rid of the fractions. I'm just going to multiply both sides by 6 because that's the common denominator. So I'm going to end up with 4x squared plus 6 equals 5x. And now I just need to subtract 5x from both sides. Okay, and now I need big D. Big D equals negative 71. And notice that in the formula, the first thing we're going to have to do with big D is square root it. So because it's negative, we have no solution. Alright, so we got a question about a cone here. And cone has a surface area of 300 centimeters squared and a slant height of 15 centimeters. And they want to know the radius of the base of the cone to the nearest hundredth of a centimeter. And they've given us a formula here, where S is slant height, so it looks like the only thing we really need to find, or the only thing missing, is R, because they've also given us the area. So we'll sub in 300 for area equals pi R 15 plus pi R squared. And now let's get everything on the same side. Subtract 300 from both sides. I get 0 equals pi r squared plus 15 pi r minus 300. Which means that my a is pi, my b is 15 pi, and my c is negative 300. So d is going to be 15 pi squared minus 4 times pi times negative 300. Notice leaving the pi's in here really reduces our rounding errors. We can just punch it all into the calculator as one thing at the end, and we'll end up with no rounding errors at all. So 15 pi squared is going to be 15 squared, 225, times pi squared, plus negative 4 times 300 is 1200 pi. So my x is going to equal negative 15 pi plus or minus all over 2 times pi. And again, now you can just punch this in as one big solid chunk into your calculator using the pi button. You'll have no rounding errors. And you'll end up with 4.82, because they asked us for the nearest hundredth. And you'll end up with negative 19.82. And of course, there's no way our radius is going to be negative. So the radius to the nearest hundredth of a centimeter is going to be 4.82 centimeters.